Hi class! Welcome back. Now we are going to have another lesson for today. In our previous presentation or video, we were able to discuss about norms. Now, before we proceed to reliability and validity, we are going to discuss first the levels of measurement. Now, in this lesson, we are going to know more about the measurement and its levels. Now let's go to the next page. Now let's define first what is measurement. Measurement is the process of observing and recording the observations that are collected as part of a research effort. So, measurement basically is the process where you get information about the subject that you are observing. It can be either by names, by simply describing it, or by simply having numbers or letters in it. So measurement is the process of getting those information about the subject. Levels of measurements are categorized for measuring variables. So measurement depends, or the level of measurement depends on the variable that you are measuring. So we have a lot of variables. So that depends on how you are going to measure it. Like for example, if you're going to measure intelligence, probably the best measure that you will use would have numbers on it. Or you're going to measure about the physical appearance, like the height, for example, small, short, or small, medium, and large, or the sizes rather. So it depends on the variable that you are measuring. The levels of measurement depends on the variable. So why level of measurement is important? The level of measurement helps to decide how to interpret the data from that variable. Like what I've mentioned in the previous slide, our level of measurement depends on the variable. And also that variable, for us to understand more of it, it will depend on the level of measurement that we use. And from the level of measurement, we can now get and interpret the data from that variable. Knowing the level of measurement helps to decide what statistical analysis is appropriate on the values that were assigned. If a measure is nominal, then you know that you would never average the data values or do a t-test on the data. So here in our class, psychological assessment, it is very necessary for us to know what kind of what level of measurement we are going to use, to know what kind of statistical tool we are going to use. For example, you've decided to have an independent variable and a dependent variable in your research or on the psychological test that you're going to administer. There will be an independent variable measuring there will be a test measuring the independent variable and another psychological test to measure the dependent variable. So since you already know the kind of variable, now you are going to know the level of measurement to measure it. So probably that will be an interval or a ratio. It depends. So from there, from there you can think of what statistical tool is best used. If you're going to review your previous lesson or your previous course or subject in psychological statistics, you can connect the level of measurement and the statistical tool used for you to identify what research process you are going to use. Okay, so basically, again, the type of or the level of measurement that you will use depends as well to your variable, and from the level of measurement you can get this. Now here are the 4 levels of measurement. So these are the nominal, the ordinal, interval, and ratio. So in others, for them to memorize this easily, they use the the acronym. Should I call it acronym? NOIR. Okay, so that's NOIR, NOIR, for them to easily remember this. So that's NOIR, NOIR, nominal, ordinal, interval, and ratio. Now let's go to it one by one. All right. Oh, it moved. Okay, it's okay. So here are the four levels. As you can see, it's like a staircase. So the lowest one would be the nominal. Next to it is the ordinal. Then we have the interval, and then the ratio. So just to give you a glimpse of it, so nominal entails to the attributes are only named. So this is the weakest. And then we have the ordinal. Attributes can be ordered. Interval, distance is meaningful, and ratio, it has an absolute zero. Now let's go to it one by one. All right, let's start first with the nominal. In nominal measurement, the numerical values just names the attribute uniquely. Okay, so for you to easily remember nominal measurement, just remember that nominal is about names. So nominal, names. So it is the first level of measurement. At the nominal level, the numerical values just name. So they can't be added or subtracted or ordered or subjected to any arithmetic process. But the numbers in each category can be counted. So in nominal measurement, you can assign simply by names. For example, male and female. And also, what else? Of course, we have girls and boys. Black and white. So these are just simply names. So for example, you are observing a person. Okay, so you are observing the behavior of that person in a specific situation. So you can say the name like, or the nominal measurement like, oh, she's kind. So that's the nominal measurement. So again, nominal entails only two names. And also, before we go to the next page, the names of it can be categorized. Okay, so and from that category, you can assign numbers in it. All right, so the names can be categorized and assign numbers with it. All right, so let's have an example. So this one is from a clinical example. All right, so for the first one, classify a group of patients into right-handed and left-handed. So you can measure someone in a clinical setting, also in psychology. If you're going to assign a person, you can just simply or measure them by right-handed and left-handed. All right, so as you can see, right-handed and left-handed are nominal measurements. And then also classify blood groups where the letter A, B, O, and AB represent the different classes. So in here, you can measure someone's blood by A, B, O, and AB rather. So as you can see, that's A, B, O, and AB. So those are simply names. Right-handed and left-handed, letter A, B, O, and AB. So those are simply names, nominal. All right, so here's another example. We can classify our observations into the categories, females and males, with one representing females and two representing males. We could use any of a variety of symbols to represent the different categories of a nominal variable. However, when numbers are used to represent the different categories, we do not imply anything about the magnitude or quantitative difference between the categories. Alright, like what I've mentioned in a previous slide, nominal measurement, from there we can categorize, okay? And from the categories, we can assign numbers, alright, just like this one. So we have the nominal measurement, like the females and the males, and then each category we have numbers on it, or it can be represented into numbers, like 1 is for female and then 2 for males. However, those numbers do not imply anything about its quantity, okay? 1 or 2 does not mean anything. It's just an assignment to it. So it does not, it cannot be used as a quantitative measurement to anything. It's just simply numbers, right? So there's no magnitude there or a quantitative meaning behind those numbers. Next, we have the ordinal. In ordinal measurement, the attributes can be rank ordered. Alright, so if we have nominal, we have names. Now we have ordinal, we have rank ordered. Ordered, ordinal. Alright, so in this level, magnitude is added for categorization. Ordinal numbers do not indicate more than rank orders of the objects. The numbers do not imply definite magnitude, nor they imply that the categories are the same in terms of the quantity that they represent. So in here, it's simply just putting the measurement into orders. Okay, so like for example, in class, so those who got 100 will be ranked first, and then those who got 99 will be ranked second. Alright, so, and then those who got 95 will be ranked third. So as you can see, there is an order. Alright, so simply there are orders, okay? There are numbers, but simply it's just for the purpose of the order. So these numbers cannot be used these numbers do not imply definite magnitude. Alright, so they are not used to quantify anything. They are just used as an assignment for it, just to make it or just to order it. Okay, so it's just simply to order the data. Alright, so the distances between orders do not have any meaning. It does not imply that the intervals between the numbers are equal. So like what I've mentioned a while ago, so people who got 100 score in a test will be ranked first. Then 98 will be ranked second, and then 95 will be ranked third. So as you can see, the rank 1, 2, and 3 are ordered. However, its equivalent does not mean that it has a definite measure. So in ordinal, you will not focus on the definite measure or the definite differences of the orders, but you're going to just focus on the rank, just 1, 2, 3. So again, 1 is equivalent to 100, 2 is equivalent to 98, and 3 is equivalent to 95. So there's no difference. You cannot define the distance between those intervals, those numbers. You are just focusing on the rank of it, that is 1, 2, and 3. The values of ordinal measurements can be measured by frequency of occurrence, by percentage of the whole, or by counting the members in the category. Ordinal measurement level is not appropriate for arithmetical computation. Simply, ordinal level of measurement can be extension to A, B, C, and then so on, in which it indicates that A is lesser than B, B is lesser than C, and so on in some property. Okay, so again, ordinal just focuses on the order. It does not, it cannot be used, the orders cannot be used in arithmetic computations. Okay, so also it can be used in frequency as well. So for example, like what I've mentioned a while ago, certain number of students got 100, they are all gonna be on rank 1. Certain number of students got 98, all of them will be ranked 2. Okay, so like what I always do in our class, I always present you who the ranks 1 to 5. Okay, and those 5 performers in our specific exam. Okay, but their arrangement doesn't have to be 199, 98, or whatever. Okay, the scores rather. It can be 100, 97, 93. That would be rank 1, rank 2, and rank 3. So in here, we're just focusing on the order. Okay, it can also be, the ranks can also be A, B, and C, our Roman numeral number 1, 2, and 3. All right, again, the main point in the ordinal is that it's just simply order or rank, and then it cannot be arithmetically computed. Alright, so let's have an example. So this one is for the clinical example, or clinical setting. In manual muscle testing, we know that muscle with grade 5 is stronger than muscle with grade 4. And muscle with grade 4 is stronger than muscle with grade 3. So numbers on an ordinal scale represent a rough and ready ordering of measurement. But the difference of ratios between any two measurement, grade 5 and 4 or 4 and 3, represented along the scale will not be the same. Just like my example a while ago. So the level of muscle of grade 5 and grade 4 would be, of course, different. Grade 5 might have stronger muscle than grade 4. Okay, or it can be interchangeable. Grade 4 students might have stronger muscles with a grade 5, but as you can see, it is in order. Okay, so grade 4 is lesser than grade 5. All right, grade 4 is greater than grade 3. So you can see there is still order in it, but it does not define, or it is not definite on its representation, because again, grade 4 can be stronger, has stronger muscles, might have stronger muscles from grade 5. It all depends. Alright, so as for nominal scale, with ordinal scales, you can use textual labels rather, instead of numbers to represent the categories. In muscle testing, we can use normal, good, fair, instead of 5, 4, and 3 grades. Alright, so as you can see, the difference between the nominal and the ordinal, the nominal we use the names. Ordinal we use names but in order. You can use it in order, alright? So, for example, names with order would be okay, so an example here is normal, good, and fair. Alright, so okay, so actually those are almost the same, but let's have easy, difficult, and hard. Okay, so those are names, but they are in order. Okay, so we know that easy is the lowest, difficult would be next to the easy, and then the hardest would be on the top. So it is ranked. Okay, so as you can see, there are names but in order. So for example, in pain scale with 5 possible levels, it is not possible to equal the difference between no and slight pain to the difference between severe and intolerable pain. These descriptors are subject to a wide range of interpretations. Okay, so in pain scale, so there can be 5 possible levels. Okay, but that can be measured. Okay, but it cannot be defined exactly how specific the pain is. Okay, you can just describe it, but you cannot quantify it or arithmetically solve it or compute it. Alright, now let's proceed to the next one. Here we have the interval. In interval measurement, the distance between attributes does have meaning. Alright? So if nominal just simply have names, ordinal simply have order, names plus order, we have here interval. The interval doesn't have just order. It also have meaning on its order. Alright? So in here, the attributes between the distance of two measures have meaning. This measurement includes all the qualities of the ordinal level measurements and also includes units that are equal in size. Also, the distances between levels are equal. This permits the use of arithmetic operations and the 0 point in arbitrary. For example, centigrade temperature measurement, where 0 does not indicate the absence of heat, but rather in an arbitrary point. Excuse me. All right. So one best example of an interval scale would be the temperature. All right. So the temperature would have 0, then 1 to so on to 100, and then 0 to negative, and then to 100. Okay. So as you can see, there are distances, and its distances is definite, and it can be computed. All right. You can compute it because 1 could be 1.1, 1.2, 1.3 before proceeding to another 1, that is 2. All right. So as you can see, there is a definite distance. It has a difference. And every distance of each number would have at least 10. So that's 1 to 1.9 before proceeding to 2, and then 2 to 2.9 before proceeding to 3. All right. And because of that, there is the possibility of arithmetic operations can be done in here. All right. So, but in here, just remember that there is no 0 in it. Okay. So in temperature, there is no absolute 0 because we have the cold, very cold, or hot, or very hot. Okay. So it has no definite 0. It does not have any definite 0. So let's have an example. So in here, examples of interval data include the measurement of temperature in degrees. So that's either Celsius or Fahrenheit. The two temperature scales have 0 at 2 points on their respective scales. Fresh water freezes at 0 degrees on the Celsius scale and at 32 degrees Fahrenheit scale. The temperature at which salt water freezes is arbitrarily designed as 0 degrees on the Fahrenheit scale. So as you can see, like what I've mentioned in my previous slide, that the temperature is one of the best example of the interval scale. But in here, you can see that there is 0 degrees. So the 0 degrees in here, though yes, it has a 0 degrees, but it does not mean that the absence of a temperature, but it means that the absence, or yes, absence of either the hotness or the coldness. Okay, but the temperature is still there. All right, the temperature cannot be 0. All right, so as you can see, my point here, one of the best examples of an interval scale would be temperature that would be either Celsius or Fahrenheit. Next, and not least, we have the ratio. In ratio measurement, there is always an absolute 0 that is meaningful. All right. So in nominal scale, we have names. The ordinal scales, we have rank ordered. Interval scales, we have the differences, and from the differences, it has meaning. In ratio, the most important aspect in here is that it has an absolute 0. And its absolute 0 has meaning on it. So the ratio scale is a fixed relation in degree or numbers between two similar things. The major difference between the two data classification of interval and ratio is that ratio data has absolute 0. Ratio data is the most frequently used class by healthcare professionals who deals with the patient's physical attributes. Alright, so how would we know if a measure has an absolute 0? So we can say that a ratio, yes, a measure has an absolute 0, and it is a measure of a ratio if it is really gone, it is really absent, it is not there. Okay, so an example of that, one of the biggest and the greatest example of that would be the heartbeat. Okay, so a heartbeat can be 0. All right, if the heartbeat becomes 0, it means it is the absence of the beating of the heart, so meaning that the person is already dead. So as you can see there, heartbeat can go faster which is arrhythmia, and then goes slower, which is bradycardic. All right, so it can be faster or slower, and it can also become zero, or it's gone, it's dead. Okay, unlike temperature, temperature can go cold, warm, very cold, and then it can be hot and very hot, and many more. But whenever it hits the zero, it doesn't mean that it's the absence of temperature, but it's still there. The temperature is still there. Okay, but the measure of it becomes zero. Unlike the heartbeat, it can be zero. It means that it's no longer beating. It no longer uh, um, receives and releases blood to the whole body, right? So, as you can see there, the difference between the interval and the ratio. Also, like with my example, it is often used in the healthcare industry. Alright, so examples of ratio data include height, weight, velocity, distance, heart rate, VO2. I don't know what's VO2. Anyway, if you know, please let me know. You have the max, the force, the torque, etc. With this latter classification, all mathematical operations are valid. Okay, so in here, since it has an absolute zero, any operations can be used to solve and to interpret the data. All right. Okay, so that's basically the whole presentation about the levels of measurement. So if you have any questions, please let me know. You can chat me in our Facebook chat messenger. So that's it for the levels of measurement. So thank you very much. I hope to see you again in our next video. So thank you. Bye for now.